In this lecture, we're going to continue our introduction to quantitative methods by addressing some examples and applications uh, that will necessitate a close examination of these numbers. And I posed this question in an earlier video of whether professional athletes make too much money. And so from a research perspective, if I pose this question, the nature of the question, how the question is asked, suggests that we're going to use a nominal scale. And using a nominal scale here, we're only going to provide respondents with two options here. People can select yes, or they can select no. The problem with this approach is that there are a limited amount of options to the respondents, and we lose a degree of precision here. So we therefore take a look at this and ask the question, is there a different way to ask the question? And there is a different way in terms of asking the question. We could use what's called a Likert scale. And a Likert scale is a scale that's used to assess attitudes and values of people, very popular scale that's used. And we transition from a nominal scale to an ordinal scale. And so in this sense, we have a range of different options for people to respond, where we have numerical values tied to verbal qualitative descriptors here. And so if people think athletes make too much money, they might select strongly agree. Others who don't feel quite as strong would select agree. People that are neutral would select the neutral option. And we see an ordered pattern to these responses here. And so in terms of understanding whether athletes make too much money or not, the question was really addressing the perceptions that people have. But do people's perceptions align with reality? So we actually have to go back a step and ask and pose the question, how much do professional athletes actually make? And so to get a valid answer to this question, we have to think about where can we get this sort of information. So can we get it from Wikipedia? The Wikipedia site is not a regulated or peer-reviewed site, so we're going to say no in terms of obtaining this information. Can we get this from the news? Maybe when it comes to the high elite, the highest paid athletes that are typically reported in the media, but not for all professional athletes. And it certainly depends on the sport in terms of where to find this information. And some professional sports actually do not report salaries. So one website that is very commonly used by media sources and other sports organizations is sportscity.com, that collects this information from professional sports organizations that releases salary information. And so what we have here are the salaries for professional athletes of four major professional sports in North America. And these were data that I compiled across 2014 and 2015. Some sports only operated over 2014, such as Major League Baseball, but the National Hockey League starts in 2014 and ends in 2015. But if we start with Major League Baseball has two leagues within it, the American League and the National League. Now, the data that I'm going to discuss here in a moment were compiled from 439 cases. Those are individual salaries of players released by those teams. The players weren't released, the salary information was released, and 429 baseball players in the National League. And when we take a look at the data, we see that in the American League, the average one-year salary for professional baseball players was over $4 million. And a similar pattern, not the exact number, but a similar value for the National League. Now, the median value, which is the middle value, is considerably less than the average or the mean. Here we see about $1.5 million, $1.65 million to the National League. And first, sort of rough diagnostic assessment of data is that when the average value, the mean, and the median are very far from each other, this is going to represent a rather skewed distribution, and that's something that we'll discuss in later units. An important statistic, a critically important statistic, is something called the standard deviation. And this is a statistic that describes how spread out a set of scores are. And in this case, the standard deviation is a number that describes how spread out the salaries are among American League and National League baseball players. And we actually see a standard deviation that's larger than the average. And so this is not very common, but this tells us that there is a very, very wide disparity in salaries for professional baseball players. The single highest salary reported in the American League was $28 million, $32 million plus in the National League, and the lowest salary paid out, as we can see, was under $500,000. So what we see is a very wide range of salaries here that account for a very large standard deviation and a average and median value that are very different from each other. If we move on to the National Football League, in a similar manner, we see the National Football League is divided up into two separate conferences. So anytime we examine data, the first thing we want to look for is the sample size. And so in this particular case, the sample size was over 1,200 athletes, in both conferences. We see an average salary, 1 year salary of $1.7 million. Once again here, we see a very different median salary than the average salary. Once again, a standard deviation that's actually larger than the average, as we saw in the case with professional baseball. And that is accounted for by the fact that there's a wide disparity in salaries among professional football players in the United States. Now, we won't step through these individually, but with the National Basketball Association, professional basketball players, our sample size was 410, sample size of 403 and 337 in the National Hockey League. And we see very similar patterns emerging. We see a standard deviation that's larger or at least approaching the magnitude of the mean, as we see here with the National Hockey League. And the median salary and mean salary, a little bit closer here than we see with the other sports and with the National Basketball Association. But once again, between the high and the low salaries, we see a very large range of data from these professional athletes. And so instead of looking at all the numbers, a very effective way to describe and capture these four different sports is through the use of a bar graph. And so what we see here on this bar graph, we have the sport along the x-axis here, and the height of the bars are representing the mean salary, the average salary depicted on the previous two slides. What we see here are the error bars. And so the error bars are a direct representation, a plus minus of the standard deviation that we had on the previous slide. And this indicates the variability in salaries around the average. And we can see here that the National Basketball Association average salary is the highest among all four sports and professional professional football players are paid the least of those four professional sports. And so the point here is that when we wish to evaluate the perception that people have with respect to whether professional athletes get paid too much, we need to actually gather up the information and present the accurate data as to how much professional athletes actually make. And this dispels some assumptions and myths that may exist. Another question that exists, we see this on television, we see this on the internet, is how much protein should people consume? And if people eat more protein, is that going to lead to bigger muscles? Well, this was a research study published in 2009 in which 6 young adult men were brought into a research lab. They went through a workout, lower body workout. They performed a bunch of weightlifting exercises. And immediately at the end of that workout, they consumed a protein drink made up of egg protein. Now, what was measured in this study, so the outcome was something called muscle FSR. This is a chemical measurement of how fast that person's muscle is making new protein. And that's really the whole point of working out and consuming protein, is to make bigger muscles. And one way, the way we make bigger muscles is to trigger the body to make more protein. And as we can see here along the x-axis, we see that the amount of protein ingested was manipulated in this experiment. So the 6 young adult men consumed different amounts of protein for every visit to the research lab. And if we think about 1 serving of chocolate milk and where it sits on this graph here, we see that 1 serving of chocolate milk delivers 8 grams of protein. Now, if we take a look at the protein ingestion amount and place it along the x-axis, that 1 serving of chocolate milk will intersect the data, the graph, somewhere here. But based upon the growth pattern, what we see here is that as a person consumes more protein, they're going to build more muscle tissue. And that 1 serving of chocolate milk isn't ideal. So beyond the 8 grams, we can see that if a person consumes 10 grams, 20 grams, their body's process for making new protein starts to increase. Now, the measurement on the y-axis is our dependent variable. This is the value that depends upon the value along the x-axis, and that's our protein ingestion. So this type of study is working towards establishing that cause and effect relationship between the 2 variables. The next thing to notice here in the actual data is that this is not a straight line across all of the experimental conditions. So this is a nonlinear growth in the effect of different protein amounts on the ability of the body to make new muscle tissue. And we start to see a plateauing effect. And what was observed in this study is that ingesting more than 20 grams of protein, it looks like it goes up a little bit, but this was determined to be not significantly different. This is a term that we will use throughout the course, most notably at the halfway point and later. When we talk about significantly different, that's a statistical definition that we'll define a little bit later. And basically what that says is that the increase in protein synthesis, the increase in building new protein, if one ingests double the amount of protein after 20 grams, is that the change would not be different from random chance, suggesting that there are diminishing returns in consuming more protein. So 20 grams out of this study is the ideal amount of protein to ingest. So we would describe this as dose dependency on protein synthesis. So dose dependency, depending upon the dose, protein synthesis will increase, but only up to a point. And so these are, so the focus of our course here is we're not really going to focus much on these biochemical measurements, but knowing how to read the graph and understanding that not everything follows a straight line. One last point here in terms of something to keep in mind when it comes to research studies and sampling is obtaining measures from people, whether it's qualitative or quantitative. And so when we examine data, where do these numbers come from? Well, they come from people that are research participants. Now, in Canada, research participants must volunteer. They cannot be compelled under any circumstances to take part in a research study. Now, if a person wants to volunteer for a research study, they're only allowed by law to do that if that person understands all the relevant information of the study. And the burden lies on the researchers, not the volunteer. So it is the researcher's responsibility to ensure that the person understands the risks, understands the benefits for participating, and these risks span a wide range of possibilities, including physical risk, psychological risk, emotional, and social. If we take a quick look at these photos on the left-hand side, here we see research participants clearly going through physical exertion. A person's riding a bike and they're breathing into a hose that's analyzing the air that they are expending from their lungs. In this lower photo, a person is having a muscle biopsy taken from their leg for experimental purposes. So you can clearly see that there's risk of physical harm. The risk may be minor, but there's always that sort of risk. But a person does not have to participate in a physical task to experience risk in a research study. Some surveys and questionnaires can ask very intrusive types of questions and can actually trigger very painful memories in people. And so all of those possible risks have to be taken into consideration with research. The potential benefits to participating, if there are benefits, that is not necessarily a requirement, have to be explained to the participants, as well as they have to understand why the research is being done to begin with. So this ends our final video of our Unit 1 introduction section.